everyone, this is the volume of rectangular prisms with fractional edge lengths guided notes. Let's get started. This first page here should just be a review. Volume is the amount of space a three-dimensional object takes up. A cubic unit is a cube that measures 1 unit long, 1 unit wide, and 1 unit high. This is a cubic foot because all side lengths measure 1 foot. We have 1 foot long, 1 foot wide, and 1 foot high. So this is called a cubic foot. To determine the volume of this cube right here, we need to determine how many cubic feet will fill this cube. How many cubic feet do you think will fill this rectangular prism? So write down whatever you estimate. But if you think about it, so like this is 2 feet. So I want to know how many cubic feet are going to fit there. And tall-wise, I know that there's going to be 2 cubic feet there. There's going to be 4 across the bottom because it's 4 feet. So there's going to be 4 cubes there, 4 cubes on top. Here on the side, there will be, 2 going that way and 2 going that way. So you can kind of get an idea of what this is going to look like. The volume of the rectangular prism is 16 cubic feet, or feet cubed. The units are cubic feet because that is what is filling the shape. So if you notice, we have 8 here in front, and then we have another row of 8 behind it. So there will be 16 cubic feet. The volume of a rectangular prism is length times width times height. So LWH is how you'll often see it, but that will be length times width times height. Now let's look at a rectangular prism with fractional edge lengths. Why can we not pack the rectangular prism with cubic feet? And that's because a cubic foot is larger than all the side length dimensions. This is 1/4 of a foot. So a real cubic foot we know would be 4 times that. And this is a half foot. And so the cubic foot's going to be bigger than that. Let's pack the rectangular prism with cubes that have 1/4 feet side length. Why is 1/4 feet a good measurement to use? It's a good measurement because 1/4 will evenly go into all side length measurements. So we have 1/4 here, 1/2, but that's just twice 1/4 and then 1/4 there. First, what is the volume of a cube with side lengths of 1/4 feet? So if these are 1/4 long, 1/4 wide, and 1/4 high, to figure out the volume of that cube, I'm going to go 1/4 times 1/4 times 1/4. Multiplying the top, I get 1. 4 times 4 times 4 will give me 64. So the volume would be 1/64 cubic feet. How many 1/4 cubic feet would fit into the rectangular prism? Well, if it's 1/4 high, so it's just going to be 1 and then 2 across because this will be 1/2. So total, there will be 2 1/4 cubic feet that would fit. So 2 times the volume of one of them would be 2 times 1/64. So 2 times 1/64, this can reduce, and I get 1/32 cubic feet. Notice that this is the same as using the formula volume equals LWH. So going back up here, my length is 1/2, my width is 1/4, and my height is 1/4. So if I just use that formula, length, which is 1/2, times height, which is 1/4, times width, which is 1/4, that gives me 1 times 1 times 1, which is 1. 2 times 4 is 8, times 4 is 32. So I can also just calculate it by length times width times height. Let's determine the volume of the rectangular prism below by packing it with cubes with fractional side length. What side length of a cube would work well? So if you notice, I have a 2/3 here and a 1 and 1/3 and a 1. So I think I could use a cube length of side lengths 1/3, and that would pack it well because that goes into 2/3 and that will go into 1 and 1/3. What is the volume of this cubic unit? So the cubic unit is going to be 1/3 times 1/3 times 1/3. And so that's going to be 1/3 times 3 is 9 times 3 is 27. So the volume of that cubic unit is 1/27 centimeters cubed. How many of the cubic units will fit into this rectangular prism? The side right here is 2/3 centimeters. So if each side is 1/3, then that's going to be 2 of them stacked. The length is 1 1/3, so that's going to be 4 of them because 3 of them will be 1 plus another third. And here is 1, so there'll be 3 there in depth. So looking at it face on, I have 8, and then I have 3 rows of that, so that's going to be 24. Each of the volume of cubes is 1/27, and there's 24 of them, so I'm going to multiply 24 times 1/27, and that can reduce. 3 goes into 24 8 times, and 3 goes into 27 9 times, so that reduces to 8/9. Notice that this is the same as using the formula volume equals length times width times height. So the length is 1 1/3, the width is 1, and then the height is 2/3. Let's change 1 1/3 to improper fraction. So that's going to be 4/3 times 2/3, and then times 1, which we don't need to write, but we will. So 4 times 2 is 8, 3 times 3 is 9. So that checks out as 8/9 centimeters cubed. To determine the volume of a rectangular prism with fractional edge lengths, you can either pack the shape with cubes of fractional edge lengths or use the formula volume equals length times width times height. Let's do some practice. Answer the questions below. Write your answer in the box. How many cubes with the side length of 1/2 inch can fill this rectangular prism? And it really helps to draw on the given diagram. So this side here, so it's 3/2 inches tall. So that's going to be 3 rows of 1/2 inch. It's 5/2 inches long. So that's going to be 5 cubes of a 1/2 inch there on the bottom. Now my spacing will not be perfect because I am just sketching. And it's 1 inch deep. So there's going to be 2 rows of a 1/2 inch. Now if I kind of draw this, I can kind of see what it's going to look like with the cubes packed. It will look something like this. So the front face looks like there's 5 times 3, so there's 15 cubes and there's 2 deep. So that would be 30 cubes. A rectangular prism has a volume of 3 inches cubed. How many cubes with the side length of 1/2 inch can fill the prism? Let's draw a rectangular prism that has a volume of 3. We'll keep it simple. So I'm thinking to have a volume of 3, I'm thinking that I'm going to have the height be 1, the length be 3, and the width be 1. That way 1 times 3 times 3 will give me a rectangular prism with the volume of 3. So I'm just going to sketch it. Now your sketch doesn't need to be perfect, but just good enough that you can understand it. Now, if I have cubes of a 1/2 inch, let's sketch where they would be. So on the side here, if this is 1 inch tall, then I'm going to have 2 cubes that are a 1/2 inch tall. And same here on the side, there'll be 2 deep. And then 3, that means there would be 6 because each of us a 1/2 inch. So a 1/2 inch goes into 3 6 times. And then just kind of connect your lines here. Again, this is a sketch. It's not going to be perfect. But on the front face here, it looks like I have 6 times 2, which is 12 cubes, and that's 2 layers deep. So 12 times 2 is 24. So there would be 24 cubes that are a 1/2 inch in side length. Determine the volume of the rectangular prism below. Instead of doing cubes, I'm going to use the formula of length times width times height. So 1 1/2 times 3/4 times a 4th. Let's change 1 1/2 to an improper fraction. So that's going to be 3/2 times 3/4 times 1/4. Multiplying across, 3 times 3 times 1 is 9. On the bottom, 2 times 4 is 8 times 4 is 32. And that would be my volume, 9/32 centimeters cubed. Determine the volume of the cube below. Now it's a cube, so that tells me that the side lengths are all the same. So they're all going to be 1/10. So using the formula length times width times height, we'll have 1/10 times 1/10 times 1/10. Multiplying across, I get 1. 10 times 10 times 10 is 1,000. So the volume of the cube is 1 over 1,000 meters cubed. Your family just put a new swimming pool in your backyard. The swimming pool is 15 feet wide, 30 feet long, and 6 feet deep. Your mom asks you to fill the pool but to leave 6 inches of space at the top. Determine how much water to put in the pool. Let's use the formula V equals LWH, or length times width times height. The length of the pool is 30 feet. The width of the pool is 15 feet. And the height of water to put in the pool is 5.5 feet. Because the pool is 6 feet tall and we need to leave 6 inches. So that's 1/2 a foot. So we're going to minus 1/2 a foot, and that gives us 5.5 feet. Now we need to multiply the above dimensions, which equals, so we need to multiply 30 times 15 times 5.5. I multiply all that together, I get 2,475 feet cubed. A company sells various size toy cubes. In one box, they packed cubes with side lengths of 1/3 feet. In another box, they packed cubes with side lengths of 1/4 feet. The box dimensions are shown below. How many more cubes of side length 1/4 feet can fit in the box than cubes with side length 1/3 feet? And it gives us this table down here to kind of help us figure this out. Let's actually start here with this width right here. So that is 1. If the cubes are 1/3, that means there's going to be 3 cubes this direction and 3 cubes that direction. So 3 and 3. Here where it's 2 feet, in 1 foot there's going to be 3. So in 2 feet there's going to be 6. Multiplying the number of cubes together, 6 times 3 is 18, times 3 is 54. There would be 54 cubes of 1/3 foot cubes inside. Okay, now let's erase this and do it for a 1/4 foot. So for a 1/4 foot, there would be 4 going across here and 4 with the depth. And with the 2 feet long, since there's 4 in 1, that would mean there'd be 8 here on the bottom. So 8 times 4 is 32, times 4 is 128. There would be 128 cubes if the cubes had 1/4 foot side dimensions. So going back up here to answer the question, how many more cubes of side length 1/4 foot can fit in the box than cubes with side length 1/3 foot? Let's subtract. We have 128 minus 54, and those are coming from right here, and that gives us 74 cubes. Practice. Answer the questions below. Write your answer in the box. Determine the volume of a room with a length of 10.5 feet, a width of 14 feet, and a height of 9.5 feet. Now, if I were to do this problem, I'm just going to go ahead and use the formula volume equals length times width times height. And do you know what I'm going to do? Instead of keeping those numbers as fractions, I'm going to change them to decimals because they are easy decimals to work with. So I have 10.5, 14, and 9.5. I just need to multiply all those numbers together, and that gives me 1,396.5 feet cubed. How many cube dice with 1/2 inch side length can fill up the container below? So if there's 1/2 inch, that means in 1 inch, I can get 2 dice because there's each are a 1/2 inch. So down here at the bottom where it's 8 inches long, if I can get 2 per inch, I'm just going to go 8 times 2 is 16. So there's 16 there across. 5.5 inch, I'm just going to times it by 2. So 11 dice tall. And 6.5 inch here, I'm going to times it by 2 because I get 2 dice per inch. And that gives me 13 dice deep. So I'm going to multiply 11 times 16 times 13. And that gives me 2,288 cubes. Okay, everybody, that's it for today. Thank you.